In this video, we're going to look at using your TI-84 or similar model graphing calculator to find zeros, relative maxima and minima, and then also state the range of this given polynomial function. So for this problem, we're given the fifth degree polynomial function f of x equals x squared plus 14x minus x to the fifth. So I'm going to head over to my graphing calculator. I'm going to click y equals, and then I'm going to enter the function x squared plus 14 times x minus x, and I'll use the caret symbol to get it to the fifth power. So you enter your function, and then you want to look at the graph. Now, obviously here we can't see all of the graph. We have a general idea of what the shape is doing. So we have a couple of options. We can manually change our window, or we could try zoom 0 or zoom out. So there's a couple options. When I'm trying to figure out what the whole graph looks like on the screen, my first choice is I generally try and pick zoom fit. Now, that's giving me way too much information because now I can't see the up and down information. So maybe I'll go back to zoom 6. I have a general idea of the end behavior. So this is an odd degree function to the fifth power, which means it has opposite ends. And because the leading coefficient on that leading term, negative x to the fifth, is negative, the graph is falling left to right. So it looks like maybe I just need a little bit of extra information on my y's. So I could come over here and I could say, instead of having my y values go from negative 10 to 10, I'll go from negative 20 to positive 20. And I can see my graph a little bit better. And again, if I want to change my window some, I already looked at the entirety of the graph using zoom fit. And then I went back to zoom 6, the standard view, which gives us a 10 by 10 window. But maybe I'll shrink my x's. So I'm going to go to window, and instead of having my x values go from negative 10 to 10, maybe I'll have them go from negative 5 to 5. And this is just a matter of, trying to make the graph look like something you want to see. Okay, so now I can see the important parts of my graph. So part A asks us to estimate the real zeros. Now, above the trace button, it says calculate. So I can hit second trace. And option 2 brings me to zeros. So I can arrow down and hit enter on option 2. I can see, looking at this graph, there are about 3 zeros. When I choose my zeros, I have these prompts down here. Now, since the cursor is already here, we can look at this first zero, or the middle zero, I guess I should say. So it says left bound. So I'm going to use my left and right arrows. I'm going to go to a little bit to the left, and then I'll go to a little bit to the right. And then you can see there are 2 arrows at the top pointing in. I think my 0 is in there. It now says guess. So I'll guess. And 0, 0 is a 0. So when x equals 0, we are crossing the x-axis. Okay? At x equals 0. So let's look at maybe this 0 over here to the left, the first one that occurred. So I'll go to second trace, which takes me to my calculate, and I'll choose option 2, and we're going to look at a different 0. So again, I'm going to use my left and right arrows, and I'm going to travel to the left side of the 0. In this situation, because the graph draws from left to right, the left 0 is slightly above. Now it says right bound, so now I'll go a little bit below. And I have 2 arrows pointing in. I guess that my 0 is in between those. And I get this value as an output, negative 1.86637. And of course, the problem in this case asks us to round to 3 decimal places. So 3 does not cause that 6 to go up, so we'll just cut those 2 digits off. And we'll do this once more. Second, calculate a 0, option 2. And I'll go over to my third 0. So I'm using my left and right arrows to travel along the graph. So in this case, again, the left bound is above, and then the right bound is below. And so again, I have two zeros pointing in. I guess that it's somewhere in the middle. You don't really have to move your cursor. You can generally just guess at that end point. And this is 2, 0. So again, this problem's asking us to round to 3 decimal places. So 2 rounded to 3 decimal places is 2.000. This graph has 1, 2, 3 zeros, and the calculator calculated them for us exactly. So obviously we can use the trace function and we can sort of get close, but that's not close enough for our needs. We want to second calculate, and then we're going to choose option 2 to find those zeros. Now, if you look here, when we hit second trace, there's also an option to calculate a minimum or a maximum. And furthermore, you might also need to calculate a point of intersection. Okay, in this case, we're not going to use option 5. But this problem is asking us to find the relative max and the relative min. So we'll go back and we'll look at our graph. So we can see there's a low valley, which represents a minimum over here on the left side of the y-axis. And then we have a mountain peak, which represents the maximum on the right side of the y-axis. So again, I'm going to choose second trace. I'm going to find the maximum first. All right, so that's option 3. I can arrow down and hit enter, or I can just type the button 3. So I picked maximum. So now again, we're going to go to the left side of the maximum, just a little to the left, but you need to make sure you are definitely on the left side, and then go to the right bound, the right side. Again, we have 2 arrows pointing in, and we'll hit guess. Oh, I must have picked minimum. So do you see how it's not at the maximum there? So we'll do second trace. We need to find a maximum, which is option 4. And again, I think I picked number 3. So again, we'll go left bound, and then we'll go right bound and guess. So left bound, right bound, and guess. And that gives us our maximum value. Okay, so that was a good learning point, because when I chose minimum and I went to find the maximum, it found the lowest point in my region, which was one of my endpoints that I had picked. So in this case, the maximum, when we state maximum values, we're going to state the maximum is the y value, and it occurs at x. So over here, we've got 0.2385. That 5 causes that 8 to turn into this 9 that we see right here. And then 1.3519, that 1 is going to turn into a 2 when I put it in my Pearson question to answer it. All right, so if you want to find the maximum, you need to choose the maximum option. And then if we want to find the minimum, we'll do second calculate. I'm going to choose option 3 for minimum. And I'm going to arrow to the left side of my minimum, the left bound. And then I will go to the right side and hit enter. Again, notice that this is my region, and I'm saying that I want to find the lowest point in between those 2 chosen values. So my guess is right here. And then again, I get my output minimum. So again, rounding, that 9 causes this last digit on my y value to go up to 2. And then for the x value, because that's a 4, we can just cut that off. So we have negative 1.232. Remember, when we state max and min values, any sort of extreme value, we're always going to say the max or min is y, and it occurs at x. Right, last thing to think about here, and this question's not asking about domain, but this is a polynomial function, and there's no denominator or no even root. So that means I can plug any x value I want in, and I'm not going to end up with, any restrictions where I end up dividing by 0, or I'm taking the square root of a negative number. So the domain of all polynomials is all real numbers. But what is the range of this polynomial? Okay, now range values extend the lowest y to the highest y. And this might be a good place to look at zoom 0 again. So zoom 0 is zoom fit, and that will try to fit the graph on the screen. If we look at zoom 0, this gives us a good general shape. Of course, we've already talked a little bit about the end behavior, but this graph, because of this leading term here, having an odd degree 5, we have opposite ends, and the leading coefficient is -1. It is falling left to right. So the graph is extending up to positive infinity over here on the left side and down to negative infinity on the right side. So the range is that all of my y values are in the span of negative infinity to positive infinity. And when we talk about range or domain, we always state least to greatest left to right. So I know we look at this and we say, hey, it goes from positive infinity down to negative infinity, but negative infinity is the lowest, up to positive infinity. So I hope that helps you with this problem. I tried to go into really good detail so you guys don't run into calculator problems and you're able to get those exact decimals like the computer wants. Please let me know if you have any questions. I am here to help.